Now we will discuss the third part, that is differential equation of linear system. Suppose that a particle is performing linear ascension, and say at the given instant the particle is at a distance x from its mean position. The restoring force acting on the particle at this position is represented by, say, F. Then mathematically we can write this restoring force F acting on the particle will be equal to minus k times x. This is the equation which controls the linear system. According to Newton's second law, this restoring force acting on the particle will produce the linear acceleration in the particle. And this linear acceleration produced in the particle as a result of this restoring force acting on it can be represented by using Newton's second law as force F, restoring force F, is equal to m into A, where m is the mass of the particle performing linear ascension and A is the corresponding linear acceleration for the given displacement x of the particle. Now this linear acceleration can be represented in differential form as the rate of change of linear velocity with respect to time, that is d by dt of t. Similarly, the linear velocity can be represented as the rate of change of linear displacement with respect to time. So, d by dt of v can be represented as d by dt of dx by dt, or it can be represented as d2x by dt. This is called first order differential equation of the linear acceleration, and this is called second order differential equation of the linear acceleration. So by using this equation we can write the restoring force F equal to m into d2x by dt. By using equation 1, F equal to minus kx, and by using equation 2, F equal to m into d2x by dt. As both equations represent the same restoring force, we can equate them, and equating we have m into d2x by dt2 is equal to minus k times x, or rearranging this equation we have d2x by dt plus k by m into x is equal to 0. This is called differential equation of linear system. In this equation, k is force constant. It is constant for the given linear system. M is mass of the particle. It is constant for the given particle. So for the given particle performing given linear system, the ratio k by m is constant, and suppose this constant is taken as omega square, where omega is called angular frequency. The angular frequency is Newton, and this omega will be equal to 2 pi by capital T, or is equal to 2 pi f, where capital T is period of linear system and f is the frequency of linear system, that is the number of oscillations performed by the particle in linear system during 1 second, that is the frequency. and time taken by the particle to complete one oscillation is called period of polarization. So this omega angular frequency is related as these equations with the angular frequency with period and frequency. So the differential equation can be represented as d2x by dt2 plus omega square x is equal to 0. This is the differential equation of linear system. This is one form, this is other form. Both are differential equations. Now, we will discuss the MCQ points. Of this differential equation. In this differential equation, this d2x by dt2 represents the linear acceleration, which is represented by a. If we rearrange this equation, we have a plus omega square x is equal to 0, or a is equal to minus omega square x. Or in magnitude, acceleration a is equal to omega square into x. Now, this equation can be used to define the linear SHM alternatively. We can say that the linear SHM is a periodic oscillator motion in which the linear acceleration produced in the particle is always directed towards the mean position, and in magnitude the linear acceleration is directly proportional to its linear displacement from the mean position. Negative sign in this equation indicates that this linear acceleration and its linear displacement from the mean position are always oppositely directed. As the linear displacement is always measured away from the mean position, the linear acceleration will be always directed towards the mean position. Now, by using these equations, we can say that in magnitude, acceleration equal to omega square into x. Omega is constant, so omega square is also constant. In other words, linear acceleration in magnitude is directly proportional to its linear displacement from the mean position. Acceleration will be minimum and have value 0 when x is minimum. That is, x is equal to 0 when particle is at mean position. So, the linear acceleration of the particle performing SHM will be 0, that is its minimum value in magnitude whenever the particle is at mean position, and the acceleration will be maximum when x is equal to x max. This maximum displacement of the particle from the mean position is represented by capital A and is called amplitude. So, x maximum is equal to capital A, where capital A is amplitude. amplitude of rest. These are either, so can be taken as plus or minus capital A. In magnitude, it is capital A. So acceleration maximum will have value omega square into A. And this maximum value will be produced by the particle illumination when the particle is at extreme position, either extreme position, that is at x equal to plus a or at x equal to minus, the magnitude will remain same, omega square into capital A, where capital A is used for the amplitude, small a is used for the linear acceleration. These are the equations for the minimum and maximum value of the acceleration. By using this equation, we can represent the variation of the linear acceleration with respect to its linear displacement from the mean position graphically by taking displacement from the mean position along x-axis and acceleration along y-axis. Now, when particle is at positive extreme position, the acceleration will have value minus omega square into A. So, this is the corresponding reference point. When x becomes 0, acceleration will become 0. When x becomes minus A, acceleration becomes plus A omega square. If we join this, we have a curve which shows the variation of the linear acceleration with respect to the linear displacement from the mean position or equilibrium position. This is straight line graph passing through origin with a negative slope. This is the concept. Now, how this concept can be changed in the questions? Suppose that in the given image, a figure is given like this, as shown in the board. This figure is given, and it is asked that a particle is performing linear system whose variation, particle performing linear acceleration, in which the linear acceleration of the particle varies as x as shown in figure. What is the angular frequency of the linear system? concept, acceleration in magnitude is equal to omega square x. In direction, it is minus omega square x. If we take the slope delta a by delta x, that is dy by dx, which is equal to slope of the graph, becomes delta a by delta x, and by definition it is from the equation of direct minus omega square. If we take in magnitude, then the slope of this equation becomes omega square. We can find out slope as 6 delta A is equal to 6 divided by delta x, which is equal to 2. So it becomes 3. So omega square is 3. So omega becomes root 3 per second. So this concept, acceleration is equal to minus omega square x, which we have studied theoretically, changes like this in the multiple choice questions. By using this, we can find out. Now, the same question can be used to ask what is the period of recession, what is the frequency of recession, what is the maximum value of acceleration. We know that it is given. A is given, omega is found out, so we can find out A omega square. So omega square can be found out, A is given in the graph, we can find out. So by giving the graph, they can ask these different MCQs to find slope, that is omega square. The second MCQ can be asked to find omega. The third MCQ can be asked to find the period. Fourth MCQ can be asked to find the frequency. Fifth MCQ can be asked to find the acceleration. So the same concept can be used in different ways to find the different physical quantities. This can be used to prepare the question like this. Suppose that this particle is performing linear SHM, and this linear SHM is represented by this differential equation, d2x by dt2 plus 16x is equal to G. The first MCQ which can be asked to find omega square or omega. If we compare this given equation with this differential equation, we can write omega square equal to 60. So, omega will be equal to 4 radian per second. So, this is simple answer. Just by comparing the given equation with the standard differential equation, we can find out. Another one is to find the thing. By using this value of the omega, which is equal to 4, also omega equal to 2 pi by capital T, we can have capital T equal to 2 pi by omega. So answer becomes 2 pi by 4, so that is pi by 1.57. The third one, once again a simpler MCQ. To find the frequency, we can find the frequency by using the equation omega is equal to 2 pi. So F will be equal to omega upon 2 pi, 4 by 2 pi, that is 2 divided by pi. Oscillations per second. So these are the simpler ones. Now the same MCQ can be used with higher effect. For example, it is stated that a particle is performing linearism along the path length and its differential equation is given by d2x by dt2 plus 16x is equal to 0. The same MCQ can be used to find the another terms. For example, the first term we can find the maximum acceleration, which is equal to a omega square. In the given example, it is given path length. So, twice a path length is equal to twice of the amplitude. Distance between the two extreme positions of the path on which the particle is performing SHM is called path length. And it is equal to, numerically it is equal to 2 times amplitude of the SHM. So we have 2 times A is equal to 10, so A will be equal to 5 centimeter. By using this value of the amplitude and omega square 16, we can have maximum acceleration as 5 into 60, that is 80 meter per second square. So this is the something different with hands. Now, if mass is given, then we have omega square, we have mass, then we can find out the K, force constant. In this way, the difficulty level of the MCQ can be increased. Or in other words, if we think about the given parameters, then we can decide by using the given parameter how many different physical quantities can be found. For example, if only this differential equation is given, d2x by dt2 plus 16x is equal to 0, we can find omega square, we can find omega, we can find capital T, we can find F. If additional amplitude is given, then we can find acceleration. The different other things can also be calculated. However, we have not discussed earlier. We have started with this differential equation, so we will discuss it later.